Hey, good morning, everyone. We'll continue. Today is January 8th. We'll go through the second problem that showed up during last night's contest, which is marked as medium. It's pretty straightforward if you know the handy data structure priority queue, which is basically a heap, and there are max heap and min heap. In this case, we want to use a max heap. Then this problem is pretty straightforward. So let's take a read at the problem now. Maximal score after applying k operations. You are given a zero-indexed integer array nums and an integer k. You have a starting score of 0. So a starting score of 0 and an array of integers. In one operation, choose an index I, such that the I is in the array. It's within the boundary of the array. It's a valid index. Increase your score by the value of this number that you chose with this index, and then replace this number with the ceiling of 1/3 of this number. So return the maximum possible score you can attain after applying exactly k operations. So I think after solving this problem during the contest, first key point is that the data structure that came to my mind is priority queue. But of course, before coming into that idea, you need to understand the problem, what it's asking us to do. The first one, it's not really helpful because all 5 numbers are 10. You should take all of them in no particular order, right? But the second problem is kind of illuminating because k is 3, but there are 5 numbers in the array, so you should take which 3 numbers so that you can get your score is the maximized. So then take a look at this one. You take apparently each time, because the number of k, the number of operations is limited. It's smaller than the number of numbers in the array. So you always want to take the maximum, the biggest number in the array possible. In this case, initially the biggest number is 10, so you want to take 10 and replace 10 with what? With the ceiling of 1/3 of the original number. Okay, so that comes the second point is how to take the ceiling. In Java, there is a math.ceil function, but that one rounds down. So in order to avoid that error, we need to cast that one to a double before we ceil it. That's the second point that I want to call out if you use Java to solve this problem. But to go back to the first point, you can see that 10 is replaced by 4. So then in the mutated array, which number is the biggest? It's 4. That's why we take 4, we increase it by 4. So 10 plus 4 is 14 now. And we replace 4 with what? With 2. Why is 2? Because 4, a third of 4, 4 divided by 3, that is 1. But then we take the ceiling, so gives us 2, right? So that is why it's 2 here. And then looking at this mutated array after second mutation, the biggest number is 3, any of these 3s, right? So we take 3 out, increase our final score to be 17, and we have exhausted the number of operations, which is 3. And we replace 3. In this case, it doesn't matter anymore because we have exhausted our options, our limited number of operations. So basically the idea, the gist of this problem is that the array keeps changing, and each time we always want to pull out the biggest number in this collection. So that's why naturally the data structure priority queue comes to my mind. Yeah, so that's it. With that said, we can quickly implement this solution. Let's see, priority queue, it's integer type, call it max heap. It is truly a max heap, priority queue, because it's descending order. So we need to have a little lambda here. let's see if, well, LeetCode is not really, browser is not smart enough to handle this. I believe it should be. So let's see. Long answer 0, return answer. And so what I'll do is that I'll be putting all of this nums into this next heap offer. Now, while k, if we haven't exhausted all of the options, so we note here that k is always a valid number, so it's both k and num's length are smaller than this upper bound, so we don't need to worry about that. We might have exhausted all of the numbers, but k is still not 0 yet, so it's safe to just use this one exit condition. And then we'll take everything out, int max heap. Oh, come on, LeetCode, you should be able to, yeah, autocomplete. That's great. And then answer plus max, and then we'll pop it back, but we'll need to mutate it. How do we mutate it is we'll use in Java, different programming languages, there are different ways. But here, the key is that we need to cast this number to be a y is max. There are errors there. We need to cast this one to be double first, max, and then divided by 3. What? Redundant cast. No, it's not redundant. Probably it needs another parenthesis. Right, let me test it out. Illegal. Oh, I think it is this. This one. This LeetCode, it requires. Let me see if this is going to make it happier. Oh, I think I should be using parentheses here instead of square bracket. This one, now it should be okay. Okay, but this one it gives me a wrong answer. Let's see, so the max under red underline is gone. I do think this cast is necessary, so let's try it one more time. Alright, yeah. So this one is accepted. Let's try it. Oh, there is test case 2. Let's try this. Alright, it's also accepted. Let me submit it. Alright, accepted. Let me try this one more time, which is, I really hope that LeetCode could be compatible enough with what the real world Java is, which is I don't need to specify the type again here. We'll see. Right, accepted. Let me submit it here. Yeah, it should be fine. Alright, accepted again. So this is my way of approaching this again. Two main things is first, we want to realize priority queue should be a natural data structure that come into your mind. We solve this because this is a mutated, constantly mutating array. We want to always get the largest number from this collection. Second is that you want to like multiple ways to solve this ceiling problem. Because I think in most programming languages, if you just do division, it's going to run down, and then you take the ceiling, it might not be always correct. So you want to cast this one to a double first, and then take the ceiling. Take the ceiling here. All right, that's my solution to this problem. Well, now let's think about the time complexity of this problem. So suppose n is num's length. Then, so in this part, time complexity is O of n, right? Because we have one for loop and we go through this for loop to put every single number into this max heap. And then here we have a while loop. So here, this while loop, the time complexity is basically k times O log n. Because this priority queue poll, this is constant, O1 time complexity. But then each time we offer this number, it needs to do max heapify. So that one is O log n. So this k, it could be equal to the number of n. In that case, the worst case scenario, it basically becomes n log n. So this is the worst case, which is basically the upper bound of this time complexity. So that dominates the entire program's time complexity. All right, the time complexity, which we always talk about the worst case. Space complexity is ON, because we store every single number into this priority queue, and this is a queue. It's not a set. We do not remove any duplicates. So the space complexity is ON. Space is ON. Again, N is this number of is the total length of this array. Yeah, I hope this explanation makes sense to you guys and it's helpful. If that's the case, please do me a favor and hit the like button. And also don't forget to subscribe and comment and share the video. That means a lot to me. Thank you so much. I'll see you guys in the next one.